Lesson 7.2, using tangent to find a side length. So in lesson 7.1, we use tangent to find the measure of an angle in a right angle triangle. Now we're going to use the same equation, tan is opposite over adjacent, to find a missing side length. Now that we have started to become familiar with the tangent ratio, we know that we can use it to find the measure of either acute angle of a right angle triangle, if we know the length of the opposite and adjacent sides to that angle. It follows that if we already know the measure of one of the angles and we know one of the sides, we can use the tangent ratio and a little bit of algebra to find the second side of the triangle. So for example, if I give you this triangle, triangle ABC, we're looking for the side length AB. So that would be the length across from that 30-degree angle. So the first thing we do whenever we solve any trig problems is we label our triangle. So our hypotenuse is right there across from the right angle. Our opposite is across from that 30-degree angle, and our adjacent is the one labeled 10. So we're looking for our opposite side. We know our angle and we know our adjacent side. So we know that tan is opposite over adjacent, and we just fill in what we know. So my angle is 30 degrees, that can go in for A, and my adjacent is 10, that can go in for adjacent. I don't know my opposite side, that's what I'm looking for. So there are only two steps I need to go through to solve this. The first step is to take the tan of the angle. So we put this in our calculator. Because we're given the angle and we're taking the tan of it, this is not the second function one. This is when you press tan of 60 or 60 tan. There is no second function involved here. So when you take the tan of the angle, you should get 1.7321. And that still equals your opposite because we don't know it over 10. So all we've done is taken the tan of 60 degrees and replaced that with our decimal. Our second step is we want to get the opposite by itself, so we need to get rid of that 10, which is on the bottom in the denominator. Because it's in the bottom, it's being divided, so to get rid of it, we do the opposite, which is multiply. So we're going to multiply both sides by that denominator 10. So on the left side, you have 10 times 1.7321, and on the right side, you have opposite over 10 times 10. And on the right side, the 10 in the denominator and the 10 being multiplied will cancel each other out, so you'd just be left with opposite. And you see that 17.321 is the length of the opposite side. So when we're solving these, we first take the tan of the angle, and then we multiply both sides by that denominator to get the opposite side by itself. So let's look at a second example. So in this example, we have the angle 45 degrees. We have side 13, and we're looking for side BC. So that's the side opposite 45. So I want you to pause the video and take a second and try it and see how you do. Okay, so we're using tan. We have to label our triangle first. So we have the hypotenuse. Across from the 45-degree angle is the opposite side, and the 13 inches is the adjacent side. So we're using tan. Tan of A is opposite over adjacent, and we can fill in what we know. So we know our angle, and we know our adjacent side, so our equation looks like this. Tan of 45 is the opposite side because we don't know it over 13. So we're going to follow the same two steps. So first we take the tan of the angle. So in your calculator, you put tan of 45 or 45 and then tan. Either way, you should get 1. The tan of 45 is 1. And you still have equals the opposite side over 13. The second step is to multiply both sides by the denominator. So in this case, our denominator is 13. So we have 13 times 1 on the left side. And on the right side, we have opposite over 13 times 13. And those 13s on the right side will cancel each other out, and you're just left with 13 equals the opposite, or the length of the opposite side is 13. Okay? In both parts of the above example, we found the side opposite the given angle. So the steps were the same and relatively simple. When working with the tangent ratio, finding the adjacent side is slightly more difficult. So the first two examples, those are the steps to find the opposite side. Now we're going to look at finding the adjacent side. So for example, if I give you this triangle and we label our sides, that's the hypotenuse, so DF is the hypotenuse. The 3.5 side is the opposite, and side EF, the one we're looking for, is the adjacent. So again, we're using tan, and we can fill in what we know. So we know that the angle is 20, and this time we know that the opposite side is 3.5, and we're looking for the adjacent side. So when you're looking for the adjacent side, it's a little bit more difficult, but it's not impossible. So this time we're going to follow 3 steps instead of 2. So the first step, just like before, is take the tan of the angle. So it's the exact same first step as when we were finding the opposite side. So we take the tan of 20 and we get 0.3640, and that still equals 3.5 over the adjacent. Our second step is we cross multiply the decimal, so the 0.364, and the denominator, which is our adjacent. So basically what that means is we're going to switch those two. So we're going to switch our decimal and our adjacent side. And then our equation then looks like the adjacent equals 3.5 over 0.3640. So all we've done is switch the denominator and our decimal. And our last step is to divide. So we do 3.5 divided by 0.3640, and we get the adjacent side is 9.6154 centimeters long. Okay, so the 3 steps to find the adjacent side is take the tan of the angle, just like we did before, cross multiply or switch the decimal and the denominator, and then divide. So let's look at the second example. So we want to find the length of DE. So take a second and see if you can do it, and come back and see how you did. Okay, so let's label our triangle. We have our hypotenuse, our opposite, and our adjacent. We're using the tan, which is opposite over adjacent, and we're going to fill in what we know. So the angle is 60, and the opposite side is 6.8. Our first step is to take the tan of the angle, so we take the tan of 60, which is 1.7321, which equals 6.8 over adjacent. Then we cross multiply the decimal and the denominator, or we switch them. And we end up with adjacent equals 6.8 over 1.7321. Our last step is to divide. And we get that the adjacent side is 3.9259 inches long. So those are the 2 types of problems we see in this section. So you either have to find the opposite or the adjacent. And the difficult part is figuring out which steps to take. So it's really important that you set up your fractions properly. Your opposite over adjacent are properly labeled so that you know that you're finding the right side length. So there's one more example, and it's a word problem. You're 12 meters away from a flagpole. When looking at the top of the flagpole, your line of sight makes a 55-degree angle with the horizontal. How tall is the flagpole? So whenever we're doing problems like this, we have to sketch a diagram. So there's my diagram. I have my flagpole, and I don't know how high that is, and I have my person looking up at the flagpole. So the person, so along the ground there, the distance between the person and the flagpole is 12 meters. And that angle down at the bottom with the ground is 55 degrees. So I have my triangle. So that line of sight, that dotted line, would be my hypotenuse. The 12 is my adjacent, and I'm looking for my opposite. So let's set up my tangent ratio. So I can fill in my angle is 55, and we said that that 12 meters is my adjacent, and I'm looking for my opposite. So I would have the tan of 55 equals opposite over 12. So my first step is to take the tan of the angle, which is 55 degrees, and I get 1.4281 equals opposite over 12. And then I want to multiply by that denominator. So I get 12 times 1.4281 equals opposite over 12 times 12. And the 12s on the right side will cancel each other out. And I'm just left with 17.1372 as the length of the opposite, which would also be the height of the flagpole. So you could say the flagpole is about 17 meters high. So that's the end of lesson 7.2. So we've learned 2 skills, but the best way to master these skills is practice. So have a look at the handouts given, make sure you try them all, and then we will continue from there.